Imagine a reality where the laws of physics are not final truths, but fragile suggestions waiting to be rewritten. Somewhere beyond the edge of certainty, theories emerge that twist space, fracture time, and question whether reality itself is even real. Parallel universes, invisible connections across impossible distances, and a cosmos that may think like a mind. Some of these ideas are dismissed. Others quietly survive. So sit back, relax, and let's step into the unknown. Imagine stepping outside, under a night sky undisturbed by city lights. Stars scatter across the darkness like sparks in a vast, invisible forge, each one distant, burning, and precise. The Milky Way stretches across the horizon, a pale, luminous ribbon, reminding us of both the immensity of the universe and our fragile position within it. In such a space, where time and distance become nearly incomprehensible, our attention is captured by a paradox as profound as it is unsettling: the Boltzmann brain. The hypothesis takes its name from Ludwig Boltzmann, the 19th century Austrian physicist whose work on entropy reshaped our understanding of thermodynamics. Boltzmann described a universe inexorably tending toward disorder, in which pockets of temporary order, rare fluctuations in the cosmic chaos, could spontaneously appear. In our modern interpretation, some theorists propose that, in an infinite cosmos governed by chance, it is statistically possible for a fully formed conscious brain to emerge spontaneously from a random assembly of particles, complete with memories, experiences, and the illusion of a life. A single, solitary mind, flickering briefly into existence, suspended in a vacuum of nothingness, perceiving a universe that may not even exist. We encounter the first challenge to our intuition here. Throughout history, humans have sought to anchor themselves in observable reality. Ancient civilizations in what is today Palestine meticulously recorded the movement of stars, tracked seasonal floods, and mapped the contours of their lands. Temples and monuments, aligned with the sun and moon, suggest a deep awareness of cosmic patterns. These people relied on consistency, on the predictable unfolding of day and night, the growth of crops, and the passage of generations. And yet, the Boltzmann brain concept asks us to imagine that all of this, everything we think we know, could be a fleeting illusion, an emergent anomaly that exists only long enough for a mind to register it before dissolving back into chaos. The scientific foundation for this idea is rooted in statistical mechanics. Boltzmann himself was attempting to explain why we observe ordered states despite the universe's overall trend toward entropy. Random fluctuations, he suggested, could occasionally produce pockets of improbably low entropy. Modern cosmologists have extended this reasoning to extreme scales, asking, if the universe is sufficiently large and old, could isolated conscious entities spontaneously form? Could a single brain, complete with the memory of a life it never actually lived, experience a universe like ours? This leads us into the philosophical thicket. How could we ever know if we are not such a fluctuation? If a mind can spontaneously arise with perfectly consistent memories and perceptions, what evidence could ever distinguish it from a mind born of ordinary biological and historical processes? Ancient historians, scribes, and philosophers pondered similar questions, albeit in different language. Records from Babylon, Egypt, and the lands of Palestine describe dreams, visions, and fleeting glimpses of a world that may not conform entirely to physical reality. Could these accounts hint at the strange possibility that consciousness itself sometimes emerges beyond the bounds of matter as we understand it? Some physicists worry that the Boltzmann brain scenario undermines our very assumptions about probability and observation. In an infinite universe, such brains could vastly outnumber naturally evolved observers like us. If that were the case, then statistically, it might be more likely that any given conscious mind, including our own, is a spontaneous fluctuation rather than a product of evolutionary history. The implication is dizzying. Everything we consider reality could be a transitory mirage, a bubble of perception briefly surfacing in a vast, indifferent cosmos. Despite the unsettling possibilities, this hypothesis is not widely accepted as a literal description of our existence. It is, instead, a provocative thought experiment, a lens through which to examine the limits of knowledge, consciousness, and probability. It forces us to confront the boundaries between physics and philosophy, mathematics and perception, the tangible and the ephemeral. In this sense, it is a cousin to the simulation hypothesis we explored earlier, a bridge between science and speculation, revealing the delicate line between what we can prove and what we can only imagine. Consider for a moment the immensity of time. The universe, measured in billions of years, has experienced epochs so vast that entire civilizations, continents, and even stars have flickered into existence and vanished. Within this immense temporal canvas, the spontaneous emergence of a single brain, by sheer chance, becomes a possibility that is theoretically small but cosmically inevitable if the cosmos endures long enough. Our own human histories, recorded meticulously in Palestine, etched into stone, clay, and scrolls, are but brief moments in this staggering panorama. How fleeting, then, might consciousness itself be, if it can arise independently of the physical histories we trust? In exploring the Boltzmann brain hypothesis, we are drawn to both awe and vertigo. Awe at the mind's capacity to ponder the unimaginable, to trace connections between entropy, probability, and consciousness. Vertigo at the fragile foundation of certainty, where even memory, perception, and experience might be provisional, contingent, or illusory. And yet, even within this unsettling possibility, there is a strange comfort. The hypothesis does not demand belief. It only invites contemplation. It challenges the boundaries of our understanding, leaving us suspended in wonder. So we continue to gaze at the night sky, tracing constellations that have guided generations of humans in Palestine and beyond. The stars themselves, distant and unwavering, seem to mock and mirror our own questions. How do we know that the universe exists beyond our perception? Could a single mind, arising spontaneously from chance alone, perceive this vastness exactly as we do, complete with a lifetime of memories and a coherent sense of self? And if so, what does that say about the nature of consciousness, existence, and the fragile thread of reality that connects us all? Perhaps, in the end, the Boltzmann brain is not simply a hypothesis to be tested, but a mirror held up to our curiosity, reflecting the limits of what we can know. And as the night stretches on, as galaxies swirl in silent orbits beyond our comprehension, the question lingers. In the infinite dance of matter and chance, are we observers of a genuine cosmos, or fleeting minds glimpsing a universe that exists only in our fleeting, improbable perception? The mystery remains, quietly inviting us to ponder, wonder, and explore. Before moving to the next mystery, if you love deep dives into mysteries like this, I put together an entire e-book dedicated to the hidden secrets of ancient Egypt. The Egypt they don't cover in school, don't show in museums, and don't explain in mainstream documentaries. The link is right below this video. Now, let's get into the next mystery. As the night sky fades into the quiet hum of thought, carrying with it the unsettling possibility that a mind might flicker briefly into existence, our gaze now turns toward a more expansive, yet equally confounding vision: the many worlds interpretation of quantum mechanics. Imagine standing on a windswept cliff at dawn, overlooking a valley bathed in soft golden light. Mist rises from a river snaking between jagged rocks, shifting and swirling in patterns too intricate to predict. Every leaf, every ripple, every breath of wind seems to hold a hidden possibility, a choice that could alter the very course of reality. And yet, in this valley of subtle complexities, we are reminded that nature itself may harbor secrets far stranger than we have ever imagined. Quantum mechanics has long defied intuition. Subatomic particles do not behave like billiard balls rolling predictably across a table. Instead, they exist in states of uncertainty, described by probabilities until observed. The act of observation itself appears to shape outcomes, a phenomenon that puzzled even the pioneers of modern physics. In the mid-20th century, Hugh Everett III proposed a radical solution. Perhaps all possible outcomes occur, each in its own branching universe. Every quantum decision, every measurement, every flicker of a particle creates a new, parallel reality. In this vision, the universe is not singular, but an endlessly branching tree with every conceivable possibility realized somewhere in the cosmic expanse. History offers subtle echoes of this concept. Ancient civilizations meticulously recorded the cycles of stars, the rise and fall of empires, and the passage of human generations, as if they sensed that reality is not always linear or uniform. In regions that today comprise Palestine, archaeologists have uncovered cities with layers of settlements built atop one another, each layer a testament to lives that once flourished, vanished, and were replaced by new realities. Could these overlapping histories be seen as an earthly metaphor for the branching multiverses of quantum mechanics? Each civilization, each generation, each individual choice might be mirrored infinitely across countless unseen worlds. The many worlds. Interpretation challenges not only our understanding of physics, but our most fundamental assumptions about causality and identity. In this framework, every choice we make, whether monumental or trivial, splits reality, creating parallel versions of ourselves living out the consequences of paths not taken. When we wake in the morning, we are unaware of the other selves who simultaneously experienced the same day differently. In a universe governed by such rules, what does it mean to act, to decide, to exist? Are we unique observers, or merely one thread among an infinite tapestry of possibilities, each thread as real and as fleeting as the next? Experiments in quantum physics provide hints that the universe may indeed behave in ways that defy classical logic. Particles appear to interfere with themselves, exist in superpositions, and instantaneously influence one another across distances, phenomena that challenge the notion of a single, unified reality. While these experiments do not prove the existence of parallel worlds, they illustrate that the quantum realm is far stranger than our everyday experience allows. Could the intricate patterns of electrons and photons reveal glimpses of the branches Everett imagined, realities that coexist alongside our own, unseen yet fundamentally connected? The philosophical implications are equally profound. Ancient philosophers and theologians from civilizations in Palestine and beyond often contemplated multiple planes of existence, unseen worlds inhabited by spiritual or celestial forces. While their frameworks differed from modern physics, their reflections echo a similar intuition: that reality may be far more layered and complex than what we perceive. Could it be that our universe is but one version among an almost unimaginable number of parallel worlds, each governed by its own unfolding story, yet interconnected in ways we are only beginning to explore? Mathematical models suggest that these branches are not fleeting anomalies but persistent structures, each evolving independently, creating a cosmic web of possibilities. The sheer scale is staggering. If every quantum event splits reality, then the universe, by now, may have spawned more branches than there are atoms in existence. Every decision, every observation, every movement of a particle contributes to this vast, intricate tapestry. Within such a framework, our sense of individuality is both profound and fragile. We are unique, yet multiplied across infinite dimensions. As we consider this, one cannot help but wonder about the narratives of human history, the lives of those who walked the hills of Palestine, tended to their fields, built cities, and observed the skies. Each life, each event, might exist in countless variations, replayed in universes we can only imagine. Every seemingly random occurrence, a coin flipped, a word spoken, a choice made, becomes a branching point, a divergence into worlds we will never directly perceive. And yet, in contemplating these possibilities, we gain a new perspective on causality, responsibility, and the extraordinary scale of reality. Perhaps the most humbling realization is this: the many worlds interpretation does not simply ask us to reconsider physics, it asks us to reconsider ourselves. If every path we do not take is nonetheless realized somewhere, what does that mean for our understanding of identity, fate, and purpose? How do we reconcile the lived reality of this world with the possibility that countless others exist simultaneously, parallel and equally valid? The universe, it seems, may be a far richer, more intricate, and more mysterious tapestry than we can ever fully comprehend. And so we return to the quiet valley, the mist curling around rocks, the river flowing in countless possible ways. The dawn light catches on each ripple, each blade of grass, as if to suggest that reality is layered, fluid, and endlessly branching. We are travelers in a cosmos that may never reveal all of its secrets, explorers tracing patterns that hint at infinite worlds beyond our own. And as we stand at the edge of this understanding, the question lingers: how many versions of ourselves exist in these unseen realms, and what might those worlds reveal about the nature of existence, choice, and the universe itself? The mystery remains, as vast and intricate as the branches of reality that may extend forever beyond our sight. As the echoes of infinite branches fade into thought, we turn our gaze inward and outward at the same time, to a world that is at once familiar and profoundly enigmatic. Picture a quiet forest at dawn. Sunlight drifts in golden slants through ancient olive trees, their gnarled trunks rising from the earth like sentinels of centuries past. A soft breeze stirs the leaves, and the distant murmur of a stream whispers across moss-covered stones. Every rustle, every ripple, seems charged with an imperceptible awareness, as though the very world around us is alive with subtle perception. In this gentle, almost sacred moment, we are invited to consider a radical possibility: that consciousness is not limited to humans or animals, but that it pervades the universe itself. The conscious universe. Theory, often called Panpsychism, proposes that awareness is a fundamental feature of reality. Unlike conventional views, which locate consciousness strictly within the brain or a particular biological structure, Panpsychism suggests that even the smallest particles may possess a form of proto-consciousness. Atoms, electrons, and quarks, though imperceptibly tiny, could in some way experience, however minimally, the flow of the universe around them. If so, the cosmos is not merely a mechanical system of forces and matter. It is a living, aware tapestry, from the tiniest particle to the vast spiral of galaxies. Throughout history, hints of this perspective have appeared in philosophy, theology, and even early science. In the lands of Palestine, ancient cultures observed natural phenomena with a reverence that suggested awareness beyond human perception. Sacred texts describe rivers that speak, winds that carry messages, and mountains that witness the unfolding of history. While these descriptions are often poetic or symbolic, they hint at an intuition that the world itself participates in consciousness. Philosophers from across civilizations, Plato in Greece, the thinkers of India, and the sages of the Levant, suggested that mind is not merely a human attribute, but a universal principle woven into the fabric of existence. Modern science provides tools to explore aspects of this notion, though the theory remains largely speculative. Neuroscience locates consciousness within complex neural networks, but even here, puzzles abound. How does subjective experience arise from electrical impulses? Why does a particular arrangement of matter give rise to the vivid, rich inner life we call awareness? Some researchers have begun to wonder whether consciousness is not emergent, but fundamental, an intrinsic property of matter itself. If true, every stone, every leaf, every star may possess a sliver of experience, contributing to a universe that is alive in ways both subtle and profound. Consider for a moment the interplay of energy and matter. Electrons orbit nuclei in patterns dictated by quantum rules. Photons ripple through space in waveforms that defy classical intuition. Could these fundamental elements, in their ceaseless dance, harbor a form of perception? Panpsychism does not imply that particles think as humans do, or that rocks contemplate the cosmos. Rather, it proposes a kind of primitive, universal sentience, an awareness woven into existence itself. The world is not merely observed, it participates, however faintly, in the unfolding of reality. This view resonates with certain historical observations. In the fertile valleys and hills of Palestine, human settlements arose in harmony with seasonal cycles, guided by a deep understanding of natural rhythms. Farmers, shepherds, and scholars noticed the subtle signs of wind, soil, and sky, interpreting them as messages, as interactions with a world that seemed to respond. Could this intuitive recognition be a reflection of panpsychism, a primal acknowledgement of consciousness embedded in all things? Modern observers may see the same phenomena in scientific terms, but the question remains, is the awareness of nature merely metaphorical, or is it something more literal, a pervasive mind beneath the apparent material order? Quantum mechanics adds another layer of intrigue. The universe at its most fundamental scale behaves unpredictably, with particles existing in multiple states simultaneously until measured. Observers seem to influence outcomes simply by the act of measurement. Panpsychists wonder, could this suggest that consciousness is not confined to living organisms, but is a property of matter itself, intimately entwined with reality? If awareness is fundamental, the universe is a dynamic interplay of perception, rather than a static expanse of matter governed solely by laws. The philosophical implications are profound. If the universe itself is conscious, then our experience of it is not separate from its awareness, but a collaboration within a greater web of perception. Life, memory, and history may be part of a continuous network of conscious experience, stretching from the microcosm of atomic structures to the vast macrocosm of galaxies. In this framework, every observation, every action, every thought contributes to a living cosmos. The hills, rivers, and ancient ruins of Palestine, preserved across millennia, are more than relics. They may be echoes of consciousness itself, participating silently in the story of existence. And yet, as compelling as this perspective may be, it remains tantalizingly elusive. How could we ever measure the awareness of a particle? How can we know whether a star, a river, or a mountain experiences the world, however subtly? Panpsychism asks not for empirical proof, but for a shift in perception, to consider that consciousness is not a rare anomaly, but a universal feature of reality, flowing through the universe as rivers flow through valleys. Standing once again in that olive grove, listening to the morning wind stirring the leaves, we are left with a sense of profound wonder. The universe, from the tiniest particle to the spiral of distant galaxies, may be alive with perception, interconnected by an invisible web of awareness that we can only glimpse in fleeting intuition. Perhaps, in the dance of matter and energy, in the rhythm of life and the flow of history, consciousness is everywhere, quietly shaping the cosmos as much as the cosmos shapes it. And as we gaze across the hills, rivers, and ancient ruins, the question lingers. If the universe itself is conscious, what might it perceive of us, and how does that perception connect us to the mysteries still waiting to be discovered? As the quiet awareness of the universe fades into contemplation, our journey now turns to a striking and profoundly unsettling idea that the cosmos itself might be a projection, a hologram, a three-dimensional illusion arising from information encoded on a distant boundary. Picture standing on a windswept plateau at twilight, overlooking the rolling hills and valleys of Palestine, the fading sun casting long shadows across olive groves and ancient terraces. The land stretches outward, every ridge, every stone, appearing solid, tangible, real. Yet what if this reality, so vivid and familiar, is not as it seems? What if the universe we perceive is merely a shadow of a deeper, hidden dimension, a projection from an unseen cosmic surface? The holographic universe theory finds its roots in the marriage of quantum mechanics and general relativity. In the 1990s, physicists began to explore the perplexing properties of black holes. They discovered that the information about all the matter falling into a black hole could, in principle, be encoded on its two-dimensional surface, the event horizon, rather than being lost within. This led to a radical extrapolation. If black holes could store vast amounts of information on their boundaries, might the entire universe itself operate on the same principle? Could every star, planet, and particle in three-dimensional space be encoded on a distant two-dimensional surface, like the pixels of a cosmic screen? Throughout history, humans have long entertained notions of layered realities. In the ancient cities and settlements of Palestine, texts and architectural alignments suggest a keen awareness of unseen forces and dimensions. Temples, observatories, and sacred spaces were built with meticulous attention to geometry, perhaps reflecting an intuitive grasp of the interconnectedness of the cosmos. Philosophers speculated about worlds beyond our perception, invisible spheres guiding life and matter. Could these observations hint at an ancient understanding of something that modern physics is only now beginning to articulate? A universe whose apparent solidity masks a deeper informational substrate. The theory is striking not only for its mathematical elegance, but for its profound implications. If the universe is holographic, then the three-dimensional world we experience is, in essence, a projection. Space, time, and matter may not be fundamental at all, but emergent phenomena arising from underlying informational patterns. Every object, every motion, every interaction could be the manifestation of data encoded somewhere far beyond our immediate perception. This perspective reframes our understanding of reality, placing information, not matter, at the foundation of existence. Quantum mechanics lends a subtle, tantalizing support to this notion. Experiments reveal that particles can exist in multiple states simultaneously, that entangled particles influence each other across vast distances, and that reality seems to choose its state only when observed. These paradoxes suggest that the universe is less a stage of fixed objects and more a web of information, a network of potentialities awaiting manifestation. If the cosmos is a hologram, then the entanglement of particles, the collapse of quantum wave functions, and the seemingly instantaneous connections across space could be the natural expressions of an underlying informational matrix, a cosmic code projected into the three dimensions we experience. Consider also the way consciousness interacts with reality. If the universe is holographic, then perception itself may play a role in shaping the projection. Ancient sages in Palestine and elsewhere described the act of observation, ritual, or meditation as a means of interacting with invisible layers of existence. While their descriptions were framed in spiritual language, they echo a scientific intuition that the mind may be deeply intertwined with the universe, that reality is not simply external but relational, a dynamic interplay between observer and the observed. Mathematical models of the holographic principle suggest that the information encoded on the boundary of the universe is immense yet finite, that the vast three-dimensional expanse we inhabit could arise from computations occurring at a distant cosmic horizon. In this scenario, the apparent vastness of space and the unfolding of time are emergent features, a kind of cosmic projection mapping information into experience. It is a vision both humbling and disorienting. The universe is simultaneously vast and intimate, tangible and illusory, real and imagined. The holographic universe theory also invites reflection on the nature of human history. The ancient cities of Palestine, layered with successive civilizations, echo the notion of reality as a complex projection. Temples and fortifications, roads and aqueducts, all preserved in stone and memory, may serve as a metaphor for the layered, informational nature of existence itself. Every artifact, every ruin, every story carries information, an imprint of reality encoded across time, waiting to be deciphered. Could our entire experience, our histories, and even our thoughts be part of a cosmic projection, unfolding according to principles encoded on a boundary we cannot directly perceive? Yet, for all its elegance, the theory remains speculative. There is no definitive experiment that can confirm the holographic nature of the universe, only hints and mathematical suggestions that push the boundaries of imagination. It is a lens through which to view reality, a framework for understanding the profound interconnectedness of matter, energy, and information. And in its speculative power lies its true allure. It challenges the very way we conceive of space, time, and consciousness, inviting us to question what is truly fundamental. As we stand on the twilight plateau, the hills of Palestine fading into the distance, the gentle rustle of leaves and the whisper of the wind remind us that the universe may be more mysterious than our senses allow. Perhaps the stars above, the mountains below, and even the smallest grains of sand contain encoded information, a vast holographic record of existence unfolding before us. And as we ponder the possibility that reality is a projection, a dance of information across dimensions beyond our perception, one question remains, quietly and persistently. If the universe is a hologram, what deeper reality lies hidden behind the shimmering projection we call life? And what might still be waiting to be revealed? As the soft glow of twilight fades over the hills and valleys of Palestine, a sense of quiet mystery hangs in the air. The ruins of ancient settlements stand as silent witnesses to lives long past, their stone walls still echoing the rhythms of human endeavor and cosmic wonder. From these layers of history, a peculiar thought emerges. What if the future could, in some way, reach back and influence the past? What if time, the most fundamental of frameworks, is not a strict arrow moving only forward, but a fluid tapestry in which cause and effect intertwine in ways we have yet to comprehend? This is the strange and compelling realm of retrocausality. Retrocausality suggests that events in the present, or even the future, might exert influence backward through time, subtly shaping outcomes that, in ordinary experience, appear to precede them. While this idea seems to contradict everyday logic, it arises naturally from the perplexing behavior of the quantum world. Experiments with particles, photons, and electrons have repeatedly revealed phenomena that defy classical notions of causation. Particles seem to know how they will be measured before they are measured. Entangled particles appear to communicate instantaneously, even across vast distances, with correlations that cannot easily be explained by conventional cause and effect. Could this hint at a deeper principle, that time itself is not strictly linear, and that the future may be entangled with the past in ways that challenge our perception of reality? History is full of observations that, while not framed in scientific terms, suggest an intuitive sense of time's fluidity. In Palestine, records from early civilizations describe dreams, omens, and celestial patterns interpreted as warnings or guidance, sometimes for events that would only unfold long after the observer had passed. The very act of recording these observations implies an awareness that the present is connected to the yet-to-come in ways that exceed ordinary understanding. Could these ancient practices hint at the same underlying phenomena that quantum physics now confronts in laboratory experiments, bridging intuition and observation across millennia? The concept of retrocausality was first seriously explored in the context of quantum mechanics during the 20th century, particularly through thought experiments designed to probe the limits of temporal order. In certain experimental setups, the outcome of a measurement seems to depend on a choice made after the particle has already been detected. These delayed choice experiments, inspired by the work of physicist John Wheeler, suggest that the act of observation can retroactively influence prior events, blurring the line between past and present. While these findings do not imply conscious manipulation of time, they do challenge the assumption that the past is immutable and the future merely a consequence. One of the most striking implications of retrocausality is its potential connection to the flow of consciousness itself. If events are not strictly bound by linear causation, could human awareness interact with time in subtle, presently undetectable ways? Dreams, intuition, and moments of premonition, often dismissed as coincidence or imagination, might, in some manner, reflect an interplay between the present mind and events yet to unfold. The ancient scholars and mystics of Palestine frequently noted such phenomena, interpreting them as messages from unseen forces or glimpses into a divine orchestration of time. Modern science may be approaching a similar realization, framed now in terms of entanglement, probability, and the strange elasticity of temporal order. Retrocausality also has profound philosophical implications. The traditional view of reality positions time as a river flowing from past to future, carrying events inexorably forward. Yet, if retrocausality is at play, then time may be better understood as a complex web, where every point is connected, and influence can, at least at the quantum scale, ripple backward as well as forward. This challenges fundamental notions of free will, responsibility, and the nature of cause and effect. Every choice, every observation, could potentially be both the product of prior conditions and a subtle influencer of events yet to occur. From a practical perspective, the effects of retrocausality appear fleeting and nearly impossible to harness at the macroscopic scale. Yet the very possibility that the future might whisper to the present, influencing outcomes in ways we barely perceive, demands that we reconsider the structure of reality itself. Are the laws of physics truly rigid and unyielding, or do they contain hidden flexibilities, subtle loopholes through which the universe's own timeline may ripple and fold? Yet, as compelling as this view may be, it remains an open question, a provocative framework rather than a proven model. How exactly consciousness influences the universe, or how reality could exist independently of observation, remains largely mysterious. Biocentrism challenges the assumption of an objective cosmos, inviting us to consider that the universe may not exist as we perceive it without life to observe and interpret it. It is a radical rethinking of the relationship between mind and matter, a proposal that reality is inseparable from the act of perception itself. Standing once again in the hills at twilight, watching stars emerge and shadows stretch across the ancient terraces, we are confronted by the profound strangeness of the universe. Perhaps consciousness is not an incidental spark in the cosmos, but the very lens through which existence is formed. Perhaps time, space, and matter emerge as part of a living, perceptive universe, where life does not merely exist within reality, but actively participates in its creation. And as we contemplate this delicate interplay between observer and cosmos, one question remains, quietly but persistently. If life shapes reality itself, what mysteries might lie hidden in the spaces between perception and the universe, waiting for us to discover? As the last traces of twilight dissolve into night over the hills of Palestine, a profound stillness settles over the ancient olive groves and terraces. The stars begin to puncture the dark sky, and the gentle rustle of the wind seems to whisper a question that has echoed across millennia. What is the true nature of reality, and where does consciousness fit within it? Here, amid the silence of both human and cosmic history, we are invited to consider an extraordinary possibility: that life and consciousness are not incidental phenomena within the universe, but rather the very fabric upon which reality itself depends. This is the essence of biocentrism. Biocentrism, as proposed by modern thinkers, challenges the conventional notion that the universe exists independently of observers. Instead, it suggests that life and consciousness are central to existence, shaping space, time, and matter in ways that science is only beginning to explore. According to this theory, the universe does not simply unfold in an objective manner. Rather, reality emerges through the lens of living beings perceiving it. Time, space, and even physical laws may exist as frameworks dependent upon conscious observation. Without life to perceive them, the universe might not possess the structure we assume it does. Historical echoes of this perspective can be traced across ancient civilizations. In Palestine, sacred texts, astronomy, and ritual practices suggest an acute awareness of the interplay between human consciousness and the cosmos. Observers noted celestial cycles, interpreted omens, and aligned structures with the heavens, implying a deep recognition that the universe was responsive, or at least intelligible, through human observation. While these early interpretations were framed in spiritual or mythological terms, they hint at an intuition remarkably aligned with modern biocentrism: that life is not merely an inhabitant of the universe, but a fundamental participant in its unfolding reality. Quantum mechanics provides modern scaffolding for this idea. Experiments repeatedly demonstrate that observation influences outcomes at the subatomic level. Particles exist in superpositions, their states undetermined until measured. Entangled particles display correlations that defy classical explanations. In a biocentric framework, these findings take on profound significance. Consciousness does not merely witness reality, it co-creates it. The universe, then, is not a passive stage upon which life performs, but an interactive, responsive arena shaped in fundamental ways by awareness itself. Consider the familiar landscapes around us: the olive trees, the flowing streams, the mountains etched with human history. In a biocentric universe, the colors we perceive, the movements we observe, and even the flow of time are intimately tied to the act of observation. The world is not an immutable backdrop. It is dynamically intertwined with the consciousness that experiences it. This is not merely philosophical speculation. It is an invitation to reimagine the hierarchy of existence, where life is not incidental but central, a co-author of reality itself. The implications extend beyond physics into the mysteries of life and the human mind. If consciousness shapes reality, then death, perception, and the continuity of experience may involve more than biochemical processes. Could memory, intuition, and even the perception of time be windows into a deeper, life-centered cosmos? Observers in Palestine, from shepherds noting the stars to ancient astronomers charting the heavens, may have intuitively grasped this principle, recognizing that the universe is inextricably bound to the beings who perceive it. Biocentrism also reframes our understanding of cosmology. Traditional models treat the universe as vast, impersonal, and indifferent. a stage of matter and energy unfolding independently of life. Biocentrism turns this on its head. Life is not a byproduct, but the organizing principle, and the seeming vastness of space, the laws of physics, and even the progression of time are meaningful only in the context of conscious experience. The stars above Palestine are not merely distant spheres of burning gas. They are part of a cosmos that is perceived, interpreted, and in some way defined by life itself. This perspective aligns with, yet also radically expands, ancient observations. The ruins of cities, temples, and settlements across Palestine are more than historical artifacts. They are evidence of conscious beings interacting with the cosmos, shaping not only their immediate environment, but potentially the very perception of reality itself. The layers of civilization, the preserved histories, and the ritualistic observances suggest an ongoing dialogue between life and the universe, a dialogue that modern science is only beginning to formalize through biocentrism. Yet, as compelling as this view may be, it remains an open question, a provocative framework rather than a proven model. How exactly consciousness influences the universe, or how reality could exist independently of observation, remains largely mysterious. Biocentrism challenges the assumption of an objective cosmos, inviting us to consider that the universe may not exist as we perceive it without life to observe and interpret it. It is a radical rethinking of the relationship between mind and matter, a proposal that reality is inseparable from the act of perception itself. Standing once again in the hills at twilight, watching stars emerge and shadows stretch across the ancient terraces, we are confronted by the profound strangeness of the universe. Perhaps consciousness is not an incidental spark in the cosmos, but the very lens through which existence is formed. Perhaps time, space, and matter emerge as part of a living, perceptive universe, where life does not merely exist within reality, but actively participates in its creation. And as we contemplate this delicate interplay between observer and cosmos, one question remains, quietly but persistently. If life shapes reality itself, what mysteries might lie hidden in the spaces between perception and the universe, waiting for us to discover? The first rays of dawn stretch across the hills of Palestine. The land awakens in gentle gradients of light and shadow. Olive groves glisten with dew. Ancient stone terraces reveal centuries of labor, and the quiet hum of life begins to ripple through valleys and streams. It is in this serene, almost sacred moment that we are confronted with a question both subtle and profound. What if the reality we inhabit is not merely observed or shaped by consciousness, as biocentrism suggests, but is actively generated by it, by ourselves, collectively, in a continuous, self-referential loop? This is the unsettling yet captivating premise of the self-simulation theory. At its heart, self-simulation proposes that the universe, or the reality we experience within it, is not only observed by conscious beings, but may in some way be a simulation created by the very consciousness that exists inside it. Unlike the broader simulation hypothesis, which imagines an external architect or programmer, self-simulation suggests that life and awareness collectively generate reality from within. The cosmos is not merely perceived. It is, in essence, a living projection of self-aware beings, constantly updated, modified, and experienced through the interplay of observation and awareness. Historical echoes of this notion appear in the philosophies and spiritual teachings of ancient civilizations. In Palestine, scholars, mystics, and astronomers noted that the cosmos seemed responsive to human observation, ritual, and moral alignment. Sacred texts hint at worlds shaped by the intentions and awareness of the living, where reality itself is intertwined with the ethical, spiritual, and perceptive faculties of humanity. While such accounts were couched in metaphor and theological language, They suggest a remarkable anticipation of self-simulation, that consciousness is not merely embedded within the universe, but that it actively participates in creating and sustaining the fabric of reality. Modern science, too, offers intriguing hints. Quantum mechanics has repeatedly shown that particles behave differently depending on whether and how they are observed. Wave functions collapse upon measurement, probabilities resolve into definitive outcomes, and entangled particles exhibit correlations that defy classical expectations. Could these observations be more than random quantum quirks? Could they indicate that the universe is not an independent mechanism, but a dynamic, self-generated reality, sculpted continuously by the act of observation? The self-simulation theory posits that conscious beings are not passive spectators. They are co-creators of the reality they inhabit, shaping it in real time, whether consciously aware of it or not. Consider the landscapes around us, the hills, the terraces, the olive trees of Palestine, each shaped by millennia of human activity. Could the very experience of walking along these paths, of witnessing their textures, of contemplating the distant horizon, feed back into reality itself, reinforcing its patterns and structures? In this view, the universe becomes a self-referential system where awareness continuously loops into reality, shaping the very world it perceives. This is not a science fiction scenario of artificial control. It is a profound reframing of what it means to exist within a conscious cosmos. The implications of self-simulation are both staggering and subtle. If reality is generated from within, the relationship between perception and existence is far more intimate than we usually imagine. Every act of observation, every thought, may contribute not only to personal experience, but to the structure of the universe itself. The ruins, the rivers, and the ancient settlements of Palestine, preserved through human observation and interaction across generations, serve as a poignant illustration. Reality is not only maintained by matter and energy, but by the continuous presence of life perceiving it. Philosophically, self-simulation challenges the boundary between observer and observed. Are we separate from the cosmos, or are we, in a fundamental sense, responsible for its manifestation? Are natural laws fixed and external, or do they emerge dynamically as part of the self-simulating process? Ancient scholars may have intuited this principle when speaking of humans as co-creators in the divine order of the universe. Today, modern physics allows us to explore the edges of this notion, where observation, measurement, and consciousness converge in a subtle interplay that shapes reality itself. Furthermore, self-simulation invites a reconsideration of temporality. If consciousness actively participates in generating reality, then past, present, and future are interconnected not only through causality, as explored in retrocausality, but through a continuous, self-sustaining loop of observation and experience. History may be preserved, memory reinforced, and events rendered stable precisely because consciousness interacts with reality in a self-referential, generative manner. In this sense, the past is maintained not solely by matter, but by the collective awareness that observes, remembers, and reflects upon it. And yet, for all its intrigue, self-simulation remains a theory on the edges of current scientific understanding. There is no experiment yet that can definitively prove the universe is self-generated by consciousness, only patterns and phenomena that hint at a deeper truth. The theory does not claim to answer every question, but rather to illuminate a radical possibility that existence, observation, and consciousness are inseparable, forming a dynamic, living feedback loop in which reality is both perceived and continuously recreated from within. As we stand once more in the quiet of the hills at sunrise, the olive trees shimmering with dew and the ancient terraces stretching across the valleys, we are left with a profound sense of awe. If the universe is self-simulating, then every act of consciousness contributes not only to personal experience, but to the very structure of reality. Life is not a passenger in the cosmos. It may be its architect, its sustaining force, and its perpetual witness. And as we contemplate the implications of this extraordinary idea, one question lingers, quietly and persistently. If we are creating the universe even as we perceive it, what hidden depths, patterns, or dimensions of reality might still await our awareness, patiently waiting to be discovered? As the idea of a self-simulating reality fades into the background like a distant echo, we find ourselves once again standing at the edge of observation itself, where the act of seeing becomes inseparable from the thing being seen. The morning light spreads slowly across the ancient hills of Palestine, illuminating stone paths worn down by centuries of footsteps. Olive trees sway gently in the wind, their branches tracing patterns that feel almost deliberate, as if nature itself is responding to an unseen presence. In this quiet stillness, a deeper question emerges. What role does the observer truly play in the existence of the universe? This question lies at the heart of the participatory anthropic principle. The landscape appears solid, continuous, and independent. Mountains stand where they have always stood, rivers carve familiar paths through valleys, and the sky stretches above in vast, unwavering silence. Yet modern physics has revealed something far more unsettling beneath this apparent stability. At the quantum level, reality does not behave as a fixed structure. Instead, it unfolds in probabilities, states of possibility that remain unresolved until they are observed. Particles exist in multiple conditions at once, their final state seemingly dependent on the act of measurement itself. This is where the participatory anthropic principle begins to take shape. First introduced in philosophical interpretations of quantum cosmology, the principle suggests that the universe is not a completed object waiting to be discovered, but a reality that becomes defined through participation. Observation is not passive, it is formative. In this view, the cosmos does not simply exist out there, independent of awareness. It crystallizes into determinacy through the presence of observers capable of experiencing it. To understand how radical this idea is, it helps to step back into history. Across ancient intellectual traditions, including those found in the regions of Palestine, early scholars and observers carefully recorded celestial movements, seasonal cycles, and patterns in nature with remarkable precision. While their frameworks were deeply symbolic and often spiritual, there is an underlying thread that resonates with modern interpretations. The idea that human awareness is not separate from cosmic order, but somehow intertwined with it. They watched the skies not as distant spectators, but as participants in a meaningful universe, one where observation carried significance beyond simple measurement. Modern science reframes this intuition in a very different language, yet the mystery remains. In quantum experiments, the behavior of particles changes depending on whether they are measured. Light behaves like a wave when unobserved, and like a particle when observed. The famous double-slit experiment reveals interference patterns that seem to vanish the moment a detection device is introduced. It is as if the universe decides how to behave only when it is being watched. But what does it mean for the universe to require observation? The participatory anthropic principle takes this question further. It suggests that observers are not accidental byproducts of a pre-existing universe. Instead, observers may be necessary components in the unfolding of reality itself. Without consciousness capable of measurement and experience, the universe may remain in a state of undefined potential, mathematical possibility without physical expression. This idea raises a profound reversal of perspective. Instead of the universe giving rise to life, life may be essential in giving structure to the universe. Standing among the layered ruins scattered across Palestine, one can feel the weight of this interplay between observer and observed. Each archaeological layer represents not only a passage of time, but also a record of human perception, what was seen, remembered, and preserved. Without witnesses, would these histories hold the same form? Or does their structure depend, in some deeper sense, on the continuity of awareness that preserved them? The participatory anthropic principle does not claim that human consciousness literally creates galaxies or dictates physical laws in a conscious, intentional way. Rather, it explores a subtler possibility, that the universe may be fine-tuned, not just for life, but through life. That the very act of observation is woven into the fabric of cosmological structure. In this framework, existence becomes relational rather than absolute. Reality is not a finished canvas, but a dynamic process involving interaction between observer and system. The universe is not simply observed, it is completed through observation. This interpretation naturally intersects with broader questions in cosmology. Why do physical constants appear so precisely calibrated for the emergence of life? Why does mathematics describe the universe with such uncanny accuracy? And why does observation seem to occupy such a privileged role in quantum theory? Some interpretations suggest that if no observers existed, the universe might not collapse into a definite state at all. Instead, it could remain an ocean of probabilities, formless, unmeasured, and undefined. Only through participation does structure emerge. And yet, despite its philosophical weight, the participatory anthropic principle remains deeply controversial. It sits at the intersection of physics, metaphysics, and epistemology, resisting any simple categorization. It does not claim certainty, it raises possibility. It challenges the assumption that reality is fully independent of awareness, without fully replacing it with a definitive alternative. Perhaps this is why the idea continues to resonate. It does not provide closure, it expands uncertainty. As the wind moves through the olive groves of Palestine, carrying with it the quiet sounds of shifting leaves and distant life, the boundary between observer and environment feels momentarily less distinct. The world appears both external and intimately familiar, as if perception itself is participating in its unfolding. The stone beneath one's feet, the sky above, the distant horizon, all seem to exist not only as physical structures, but as experiences completing themselves through awareness. And so the question remains suspended in this delicate space between physics and philosophy. If observation plays a fundamental role in shaping reality, then what exactly is the universe before it is observed? And who, or what, is doing the observing when no one is looking? The sun dips low over the rolling hills of Palestine, casting long shadows across terraces carved by centuries of human hands. In the distance, the whisper of wind through olive groves mingles with the faint calls of birds returning to their nests. There is a stillness here that feels almost sacred, a quiet space that invites reflection. In this moment, one cannot help but wonder, what is the nature of consciousness itself, and how does it arise in the living world? Is it simply the product of complex chemistry, a byproduct of neural connections? Or could it be something far more fundamental, woven into the very structure of reality? This question lies at the heart of the Orch-OR, or Orchestrated Objective Reduction, consciousness theory. Developed in the late 20th century by physicist Roger Penrose and anesthesiologist Stuart Hameroff, Orch-OR proposes a radical and controversial idea. Consciousness is not merely an emergent property of the brain. Rather, it may arise from quantum processes occurring at the microscopic level, within the very architecture of neurons themselves. Tiny structures called microtubules, the scaffolding of cells, could act as quantum processors, orchestrating moments of consciousness through discrete, non-computable events. To appreciate the strangeness and the elegance of this theory, Consider the brain as you might consider the hills and valleys of Palestine. From a distance, the terrain appears orderly, predictable, a network of slopes and ridges that obey gravity and geology. But at a microscopic scale, the land reveals astonishing complexity: hidden caves, intricate fissures, subterranean rivers. So too, Orch-OR suggests, with consciousness. While neuronal networks give the impression of continuous thought, at a deeper level, consciousness may be punctuated by quantum events that collapse possibilities into definitive experiences. Thought, awareness, and self-reflection could be quantum processes orchestrated across billions of microscopic structures. Historical perspectives offer a curious parallel. Across civilizations, humans have long pondered the nature of mind and soul. In Palestine, ancient scholars and mystics observed not only the heavens but the mind itself. They sought to understand how awareness shapes experience, how dreams, memory, and perception interact with reality. While these observations were couched in spiritual language, they reflect an enduring fascination with the mechanics of consciousness, a fascination that now finds echoes in modern physics. Orch-OR, however, is not merely philosophical speculation. The theory is grounded in attempts to link two of the most profound mysteries of science: the quantum behavior of matter and the subjective nature of experience. Penrose argued that classical physics alone cannot account for consciousness. Certain aspects of awareness, such as understanding and insight, are non-computable. Meanwhile, Hameroff proposed that microtubules within neurons provide the necessary quantum environment for these non-computable events to manifest. The result, they suggest, is a universe in which consciousness is not an epiphenomenon, but a fundamental feature arising from quantum processes that could be deeply embedded in the fabric of reality itself. Consider, for a moment, the implications. If consciousness emerges from quantum events in microtubules, then awareness is not only a product of life, it is connected to the fundamental principles of physics. The collapse of quantum states that shapes the tiniest scales of matter could simultaneously give rise to the flow of thought, the spark of insight, and the continuous thread of self-awareness. In this sense, the mind is both biological and cosmological, bridging the worlds of the living and the subatomic. In Palestine, one can almost feel this connection between life and cosmos. The ancient terraces, the delicate balance of ecosystems, the human gaze tracing stars above, all suggest a continuum between observer and observed. Orch-OR deepens this continuum, proposing that consciousness is not merely shaped by the brain, but is a manifestation of universal principles, intimately linked to the structure of reality. Perhaps awareness is not confined to the skull, but resonates with the universe in ways we are only beginning to fathom. Yet, the theory remains controversial. Many neuroscientists and physicists question whether quantum effects could survive the warm, wet environment of the brain long enough to influence cognition. Skeptics argue that Orch-OR may overreach, attempting to link disparate phenomena without sufficient empirical evidence. And yet, experiments continue, exploring the behavior of microtubules, testing the limits of quantum coherence, and probing the nature of awareness itself. With each new finding, the boundary between the material and the conscious grows more enigmatic. Orch-OR also invites reflection on the mysteries of life and death. If consciousness is rooted in quantum processes, could aspects of awareness exist beyond the immediate firing of neurons? Could memory, intuition, or the sense of self transcend classical boundaries, persisting in subtle, hidden ways? Ancient traditions hinted at these possibilities through concepts of the soul, spirit, and enduring awareness. Now, physics and biology offer a new lens through which to explore these age-old questions. As evening falls, the hills of Palestine bathe in a golden glow. The wind carries the scent of earth and olive, a reminder of cycles that have endured for millennia. In this quiet, one senses both the fragility and the profundity of consciousness. Orch-OR challenges us to consider that the mind may not be a mere product of evolution or neural complexity, but a fundamental feature of the universe, orchestrated at the quantum scale, shaping reality as it arises. And so the question lingers, unresolved and tantalizing. If consciousness emerges from the quantum fabric of the brain, what deeper connection might it reveal between mind, matter, and cosmos? What hidden layers of awareness await discovery just beyond the edge of perception, quietly orchestrating the reality we take for granted? As the implications of Orch-OR linger, where consciousness itself seems to emerge from the deepest quantum layers of the brain, we are led further inward, and paradoxically further outward, toward a question that strips reality down to its most essential form. In the quiet hours before dawn over the landscapes of Palestine, the world feels suspended in stillness. Olive trees stand motionless in the pale light, stone paths retain the memory of countless footsteps, and the air itself seems charged with something invisible yet structured. It is as if beneath all things, beneath matter, beneath mind, there is something more fundamental still: information. This is where the Information-Theoretic Universe Theory begins to take shape. The phrase often associated with this idea, "it from bit," was introduced by physicist John Archibald Wheeler in the late 20th century. At first glance, it sounds almost poetic, even cryptic. It, the physical world, the stars, galaxies, atoms, and living beings, arises from bit, the fundamental unit of information. In other words, reality may not be built from matter or energy in the way classical physics once assumed, but from binary choices, distinctions, and encoded information at the deepest level of existence. To imagine this, picture the ancient stone structures scattered across Palestine, weathered by centuries of wind and time. To the eye, they are solid matter, stone upon stone, arranged with human intention. But in the language of it from bit, even this solidity becomes secondary. What matters is not the stone itself, but the information that defines its structure, its position, its state, its relation to everything around it. Reality, then, is not substance first, but description first. This shift in perspective is subtle, yet profound. Modern physics has gradually moved closer to this viewpoint without fully embracing its philosophical weight. In quantum mechanics, particles are not defined as fixed objects, but as probabilities, mathematical descriptions of potential outcomes. Only when measured do these probabilities resolve into concrete events. Before that moment, reality exists as a set of encoded possibilities, as if the universe is waiting for information to be extracted. But who, or what, is doing the encoding? Wheeler suggested something deeply unsettling and yet strangely elegant, that the universe is participatory at its core. Reality does not exist in a fully defined state independent of observation. Instead, it becomes real through acts of measurement, through interactions that produce information. Every photon detected, every particle measured, every event observed contributes to the ongoing construction of the universe as an informational structure. In this sense, the cosmos resembles not a machine, but a process, one in which information is continuously generated, refined, and realized. Ancient observers in regions such as Palestine may not have described the universe in these terms, but their relationship with the world carried a similar sense of encoded meaning. The careful tracking of celestial movements, the recording of seasonal cycles, the interpretation of natural patterns, all suggest an intuitive awareness that reality is readable, that the world carries structure which can be decoded. The heavens were not random, they were legible. Time itself seemed to contain messages waiting to be interpreted. In the it from bit framework, this intuition becomes literal. The universe is not merely understandable, it is fundamentally informational. Yet this raises a question that echoes across modern physics. Where does this information reside? Some interpretations suggest that information is not stored within space-time, but is space-time. In other words, the geometry of the universe, the shape of space, the flow of time, the curvature of gravity, may itself emerge from underlying informational relationships. Black hole physics has strengthened this idea. The surprising discovery that the surface area of a black hole, not its volume, encodes its information content, suggests that reality may be far more holographic and data-driven than previously imagined. In this view, even the fabric of existence behaves like a kind of cosmic computation. But computation implies rules, and rules imply a deeper structure still. If everything reduces to information, then what defines the language in which that information is written? Is there a foundational code of reality? And if so, what is it grounded in? The Information-Theoretic Universe. Theory does not provide definitive answers. Instead, it reframes the question entirely. It suggests that asking what the universe is made of may be less fundamental than asking what the universe means. Matter, energy, space, and time may all be emergent expressions of informational relationships, patterns of distinction between states. Even human consciousness, in this framework, takes on a new dimension. If reality is informational at its core, then perception itself becomes an act of decoding. Every thought, every observation, every moment of awareness is a transformation of information into experience. The boundary between observer and observed begins to blur, not because reality is illusory, but because both may be expressions of the same underlying informational process. Standing among the ancient landscapes of Palestine, where generations have interpreted the world through language, symbol, and observation, this idea gains a quiet resonance. Human history itself can be seen as an accumulation of encoded meaning, records carved into stone, written into text, and carried in memory. Each artifact is not just matter, but information preserved across time, waiting to be read by future observers. And yet, the deeper mystery remains untouched. If everything is information, then what is the origin of the system that generates it? Is the universe a self-contained informational loop, endlessly computing itself into existence? Or does this informational structure point beyond itself to something we cannot yet conceptualize, a foundation more abstract than physics itself? As the night deepens and the stars begin to emerge over Palestine, scattering light across the sky like fragments of an ancient code, the question lingers in the silence. If reality is fundamentally informational, then what exactly is being informed? And who, or what, is ultimately reading the universe as it unfolds? As the idea of a universe written in information fades into the background, like a code slowly dissolving into meaning, we are left standing at the edge of an even more unsettling question. What if nothing we observe is truly free at all? What if every measurement, every experiment, every apparent choice has already been accounted for, woven into a structure so complete that even uncertainty itself is only an illusion of perspective? In the quiet hours before dawn over the ancient hills of Palestine, the world feels suspended in a fragile stillness. Olive trees stand motionless in the cool air, their branches tracing patterns that seem almost intentional. Stone paths carved by generations disappear into the horizon, as if history itself is not unfolding, but already written. In this stillness, the concept of time begins to feel less like a flow and more like a structure, complete, fixed, and strangely inevitable. This is where superdeterminism begins to take shape. At its core, superdeterminism is a radical reinterpretation of quantum mechanics and the nature of reality itself. It challenges one of the most deeply held assumptions in modern physics, that experimenters are free to choose how they measure a system, and that those choices are independent of the systems being measured. In standard quantum theory, this freedom of choice is essential. It ensures that measurements are not secretly coordinated with the particles being observed. But superdeterminism suggests something far more constrained. It proposes that everything, including the decisions of observers, the configurations of experiments, and the behavior of particles, has been determined since the very beginning of the universe. Not just influenced, but fully encoded in the initial conditions of reality. Under this view, what we interpret as randomness or free choice may actually be the unfolding of a perfectly predetermined cosmic structure. The implications are profound and deeply unsettling. To understand the weight of this idea, consider how we experience reality moment by moment. A scientist in a laboratory sets up an experiment. A measurement is chosen. A detector is activated. The outcome appears random, governed by probability. Yet superdeterminism asks a piercing question. Was the choice of measurement ever truly independent? Or was that decision itself part of a vast chain of causality stretching back to the very origin of the universe? In this framework, even the act of questioning reality is already part of what reality has arranged. Across history, civilizations in regions such as Palestine observed patterns in nature with a sense of order and inevitability. The cycles of seasons, the movement of stars, the repetition of natural rhythms, all suggested a world governed by underlying structure. Ancient thinkers often interpreted these patterns as expressions of divine order or cosmic necessity. While their language was symbolic, the intuition they expressed resonates strangely with modern deterministic ideas, that reality is not chaotic, but deeply ordered in ways that may exceed human understanding. Superdeterminism pushes this intuition to its extreme logical conclusion. One of the most famous challenges in quantum physics is Bell's theorem, which suggests that no local hidden variable theory can reproduce the predictions of quantum mechanics if measurement choices are truly independent. Experiments over decades have supported quantum mechanics, seemingly closing the door on classical determinism. Yet superdeterminism reopens that door, not by rejecting the experimental results, but by questioning the assumption of independence itself. If everything, including human decision-making, is correlated from the outset of the universe, then the apparent randomness in quantum experiments may be the result of hidden correlations so deep and fundamental that they are effectively impossible to disentangle. In such a universe, nothing is truly random. Nothing is truly chosen. And yet, this is not a simple return to classical physics. Superdeterminism does not describe a mechanical universe of billiard balls following predictable paths. Instead, it describes a reality so intricately interconnected that every event, every thought, every observation is part of a single, inseparable unfolding structure. The universe is not just determined. It is holistically constrained, where every part reflects the whole. Standing among the layered histories of Palestine, where civilizations have risen, transformed, and left traces of their existence in stone and memory, one begins to sense how deeply patterns can persist across time. Each archaeological layer feels like a frozen moment in a vast sequence, as if history itself were not merely recorded, but structurally embedded into the fabric of existence. If superdeterminism is correct, then even the act of uncovering these layers, of interpreting them, was never accidental, but always part of the unfolding script. Yet here lies the philosophical tension that makes the theory so haunting. If all choices are predetermined, what becomes of scientific inquiry itself? What does it mean to test a hypothesis if the outcome of the test was never uncertain? And more intimately, what does it mean to experience agency, to feel as though decisions are made freely, if that feeling is itself part of a pre-written structure. Superdeterminism does not deny experience. It questions its interpretation. From within the system, everything still feels open. The future still appears unwritten. Possibilities still seem to branch and unfold. The illusion of choice remains intact because it is embedded within the deterministic structure itself. In this sense, awareness does not escape determinism. It participates in it, fully and continuously. Some physicists argue that this idea, while logically possible, is difficult to test, and therefore remains outside the boundaries of empirical science. Others suggest that it may offer a way to resolve lingering paradoxes in quantum theory, particularly those involving entanglement and non-local correlations. But even among its supporters, superdeterminism remains controversial, not because it contradicts observation, but because it reshapes the meaning of observation itself. As night settles once again over the hills of Palestine, the sky appears filled with silent inevitability. Stars follow paths that have not deviated for billions of years. The wind moves through valleys in patterns both familiar and unpredictable. And yet, under the lens of superdeterminism, even unpredictability becomes part of a deeper, hidden order, one in which nothing could have unfolded differently than it has. And so the question remains, lingering in the stillness between thought and observation. If every choice, every measurement, and every moment has already been encoded in the structure of reality itself, then what, if anything, does it truly mean to say that anything was ever uncertain at all? As the implications of superdeterminism settle into the mind, with its quiet suggestion that every choice and measurement may already be inscribed into the universe's grand tapestry, one begins to look beyond the constraints of a single temporal sequence. If time and causality are not as free as we feel, perhaps the universe itself is not linear, not a single trajectory stretching from past to future, but a vast, repeating cycle. A rhythm of creation and dissolution that has no ultimate beginning and no final end. Over the arid plains and rolling hills of Palestine, dawn emerges in soft, muted colors. Olive groves glisten with dew, ancient stone terraces reveal their layered history, and the quiet hum of life continues as it has for millennia. Here, one cannot help but sense continuity, the persistence of form and pattern across generations. The landscape seems almost eternal, a reflection of cycles far grander than human perception. And in this timeless quality, the idea of a cyclic universe finds a strange resonance. The Cyclic Universe Theory, sometimes called the oscillatory or phoenix universe, proposes that the cosmos does not begin with a single explosive moment, the Big Bang, nor will it end in a cold entropic silence. Instead, the universe undergoes repeated cycles of expansion and contraction, birth and rebirth, creation and collapse. Each cycle, some physicists suggest, may span trillions of years, with the universe expanding outward, then reversing into a contraction, compressing all matter and energy before igniting a new cycle of expansion. This theory is not merely speculation. Its roots can be traced through centuries of cosmological thought. Ancient cultures, including civilizations in Palestine, often understood time as circular rather than linear. Calendars, festivals, and agricultural cycles reinforced the perception that life itself moves in repeating patterns. The heavens were observed not as a one-off event, but as a series of eternal rhythms: the rise and fall of stars, the waxing and waning of the moon, the return of planets to familiar alignments. Could it be that the universe itself mirrors these cosmic cycles, on scales so vast they dwarf even the deepest human comprehension? Modern physics began exploring cyclic models in earnest in the 20th century, as cosmologists questioned whether the universe would expand forever or collapse back into itself. Observations of cosmic microwave background radiation, the distribution of galaxies, and the subtle curvature of space-time suggest that a complete understanding of the universe may require looking beyond a single epoch. The Cyclic universe theory posits that each cycle could leave faint imprints on the next, remnants of a previous existence embedded in the very fabric of space-time. These faint echoes might be encoded in the distribution of galaxies, in the polarization of cosmic radiation, or even in the fundamental constants that govern physics itself. The theory also resonates with the human perception of time and memory. Just as civilizations in Palestine record their history in layers of stone and text, leaving traces for future generations to uncover, the universe itself might carry the imprint of previous cycles within its structure. Could the stars, galaxies, and cosmic voids be reading like a cosmic palimpsest, a record of existence written and rewritten through countless eons? And if so, what mysteries from past cycles might still be hidden, shaping the patterns we observe today without our awareness? Some modern variants of the cyclic universe theory attempt to integrate it with quantum physics and the nature of dark energy. Certain models suggest that the bounce from contraction to expansion is mediated by quantum processes, preventing a singularity, a point of infinite density, from ever truly forming. In this sense, the universe avoids the ultimate destruction predicted by classical cosmology, instead finding a mechanism to renew itself endlessly. This perspective offers a subtle but profound shift in thinking. The universe is not a fragile one-time event, but a resilient system, capable of perpetual renewal. Yet the theory raises as many questions as it answers. If cycles are infinite, what governs the variations between them? Are they identical, or does each iteration carry subtle differences, a gradual evolution encoded in the passage of time? Could memory or information persist across cycles, shaping the formation of galaxies, the laws of physics, or even the emergence of life itself? And, most intriguingly, what does it mean for our own existence if the universe is an eternal recurrence? Are we merely witnesses to one of countless cycles, our lives unfolding like brief, repeating notes in a cosmic symphony? As the sun rises higher over the terraced hills, casting long shadows across fields and valleys, one can almost sense this rhythm in the world around us. Seasons return with predictable regularity, seeds sprout and die in endless repetition, and the human experience continues its own cycles of growth, decay, and renewal. It is a small reflection of what the universe might be doing on incomprehensible scales, a reminder that even amidst seeming chaos, patterns endure. Cyclic models also invite reflection on the boundaries of time and causality. If the universe is endlessly reborn, then beginnings and endings are illusions, and the linear narrative of history becomes just one perspective within an eternal loop. Space and time themselves may be part of this ongoing oscillation, with each contraction and expansion subtly shaping the framework of existence. In this sense, the universe is not merely a stage on which life plays out. It is an actor in its own continuous drama, a self-renewing system in which each cycle sets the stage for the next. And so, as night falls over Palestine, painting the hills in deep blue and gold, the mind returns to the central question. If the universe repeats endlessly, do we perceive merely one cycle among countless others? Are the mysteries we see today remnants of what has already occurred, hints of cosmic histories that predate our understanding? The cyclic rhythm of existence may be far larger than any human life, yet intimately connected, echoing through the stars, the earth, and the consciousness that observes it. In this quiet reflection, the theory leaves us with a haunting, beautiful possibility that the universe, like the land beneath our feet, endures beyond comprehension, eternally cycling, forever renewing itself, and perpetually inviting us to wonder what lies hidden in its infinite repetitions. As the idea of an endlessly cycling cosmos begins to settle, suggesting that the universe may rise, fall, and rise again, another layer of possibility emerges, one that bridges the boundary between the infinitely large and the infinitely small, the beginning and the end. Over the windswept hills of Palestine, where ancient olive trees cast long, intricate shadows on the stone terraces below, the notion of continuity and renewal feels almost tangible. Here, time seems less like a linear arrow and more like a delicate thread, weaving generations, civilizations, and perhaps entire universes into a single, intricate pattern. The conformal cyclic cosmology theory, proposed by the renowned mathematician and physicist Roger Penrose, offers a strikingly elegant vision of cosmic renewal. Unlike traditional cyclic models, which envision the universe expanding and contracting in grand pulses of creation and destruction, CCC suggests a more subtle rhythm, an infinite sequence of eons, each arising from the end of the previous, where the ultimate death of one universe seeds the birth of the next. In this framework, the cosmos is not simply reborn in a fiery collapse, but rather transforms through a profound continuity of structure, a cosmic whisper that persists across eons. Imagine standing on the edge of the Dead Sea, its placid waters reflecting the soft orange glow of sunset. Beneath the surface, the water is salt-heavy and dense, a remnant of millennia of evaporation and accumulation, yet its calm surface mirrors the sky above. This is the kind of duality CCC evokes, an end that contains the seed of a beginning, a conclusion that seamlessly becomes an origin. In Penrose's vision, the universe's distant future, when all stars have burned out, galaxies have drifted apart, and matter has decayed into radiation, may compress into a state devoid of scale. And in this scale-free condition, the universe can undergo a conformal transformation, a stretching of space-time, which paves the way for a new eon to emerge. This theory is grounded not in philosophy alone, but in subtle clues hidden in the cosmos. Penrose and his collaborators have studied patterns in the cosmic microwave background radiation, faint imprints of the universe's infancy. Some of these anomalies, concentric circles of unusually low variance in the background radiation, have been interpreted as echoes of cataclysmic events from a previous eon, perhaps collisions of supermassive black holes that occurred billions of years before our universe's Big Bang. Could these faint signatures, tiny and nearly imperceptible, be whispers from a prior universe, preserved across the vastness of time? CCC challenges our conventional understanding of beginnings and endings. In this model, the Big Bang is not a singular event, a sudden ex nihilo eruption, but the natural continuation of a pre-existing cosmic story. Each eon leaves subtle fingerprints on the next, as though the universe itself carries a memory of what came before, encoded in the fundamental structure of space-time. It is a cosmos in which creation and destruction are inseparably intertwined, each transformation a necessary step in an endless chain of rebirth. The philosophical implications of CCC are profound. For millennia, humans in regions like Palestine observed the heavens as eternal, cyclical, and interconnected. From the rise and fall of empires to the measured movements of stars and planets, ancient astronomers intuited patterns that echoed far beyond the human scale. In a sense, CCC provides a scientific reflection of that intuition, suggesting that the universe itself may possess a memory, an inherent continuity that defies the simple notion of beginnings and endings. Modern physics, too, grapples with the notion of continuity across eons. The late stages of cosmic evolution, dominated by dark energy, are typically described as a cold, empty, and entropically exhausted universe. Yet, CCC posits that this end is not a terminus, but a transition. The smooth, scale-free radiation that remains in the far future may undergo a subtle transformation, erasing scales and mass, allowing the universe to enter a new phase, its next eon, without violating the laws of physics. Each cosmic death becomes the prelude to a new creation, elegantly sidestepping the problems that challenge other cyclic models, such as the accumulation of entropy across cycles. As one walks through the quiet streets of an ancient city in Palestine, stone buildings rise like monuments to continuity, their walls bearing the marks of countless generations. Here, the echoes of human history feel almost tangible, a reminder that time is layered, cumulative, and cyclical on scales both human and cosmic. Could the universe itself operate in a similar fashion, where the end of one eon subtly imprints the beginning of the next? And if so, what hidden messages or patterns might we be able to discern, just as archaeologists uncover relics of civilizations long past? Yet, despite the elegance of the theory, many questions remain unresolved. Can these faint imprints in the cosmic microwave background truly be traced to a prior eon, or are they merely statistical anomalies? Is the transformation from one eon to the next truly seamless, or are there moments of profound discontinuity hidden in the depths of space-time? And most intriguingly, what does it mean for our understanding of causality, of destiny, and of the very nature of time itself, if the universe is a never-ending succession of eons, each born from the death of its predecessor? As night settles across the hills, the stars appear in vast constellations, each one a blazing remnant of nuclear processes that have persisted for billions of years. In the framework of CCC, these stars are not just witnesses to our current cosmic age. They are echoes of previous universes, reminders of cycles that stretch beyond comprehension. The sky becomes a tapestry of memory and possibility, of endings that are beginnings, of creation that contains the seed of its own renewal. And so, as the darkness deepens and the wind moves gently through the olive groves, one is left with a profound and humbling question. If the universe is an eternal sequence of eons, endlessly cycling from death to rebirth, then what remnants of past universes lie hidden in the present? Are we glimpsing, in the cosmic microwave background and the faint patterns of the heavens, the whispers of worlds long gone, quietly guiding the birth of the universe we call home? The mystery endures, inviting us to look, to wonder, and to contemplate the profound continuity that may underlie all of existence. As the idea of cosmic eons fading into one another settles into silence, as if the universe itself were breathing through endless cycles of birth and transformation, our attention shifts once again, this time away from the grand architecture of time and towards something far more intimate, almost hidden beneath everything we perceive. In the stillness of early morning over the ancient landscapes of Palestine, mist gathers softly in the valleys between hills. Olive trees stand rooted in soil shaped by thousands of years of human presence, their twisted branches holding the memory of seasons long past. Stone paths, worn smooth by countless footsteps, seem to sink into the earth as if dissolving into something deeper than history itself. Here, the ground beneath our feet feels solid, undeniable. But even solidity, physics now suggests, may not be what it seems. This is where the idea of emergent gravity begins to take shape. For centuries, gravity was understood as one of the most fundamental forces in nature. From Newton's vision of an invisible attraction pulling objects together, to Einstein's profound reimagining of gravity as the curvature of space-time itself, it has always been seen as a foundational feature of reality, something built into the very structure of the universe. Planets orbit stars because space is curved. Apples fall because mass bends the fabric of existence. Galaxies form because gravity weaves matter into structure across cosmic time. But what if gravity is not fundamental at all? What if it is something deeper and more unexpected, emerging from underlying information, entropy, or microscopic degrees of freedom that we have not yet fully understood. This is the unsettling possibility proposed by emergent gravity theory. Rather than treating gravity as a basic force, some modern theoretical frameworks suggest that it might be a secondary phenomenon, much like temperature or pressure, properties that arise not from individual particles alone, but from the collective behavior of vast systems. In this view, space-time itself may not be the most basic layer of reality. Instead, it could be a kind of emergent medium, shaped by deeper informational or quantum structures beneath it. To imagine this, consider the quiet stone terraces scattered across Palestine, built layer upon layer over generations. From a distance, the structure appears solid, unified, permanent. But up close, it is revealed to be a collection of individual stones, each placed with intention, each contributing to something larger than itself. Emergent gravity suggests that space-time may function in a similar way. What we perceive as continuous curvature and gravitational pull could be the macroscopic result of countless microscopic interactions we cannot yet directly observe. In the early 21st century, physicist Eric Verlinde proposed one of the most discussed versions of this idea. He suggested that gravity might be an entropic force, emerging from the tendency of systems to move toward states of higher entropy or disorder. In this interpretation, gravity is not something that pulls objects together in the traditional sense. Instead, it arises naturally from how information is distributed and rearranged in the universe. Matter moves not because it is directly attracted by a force, but because the underlying information structure of space-time evolves in a way that produces what we perceive as attraction. It is a subtle but profound shift in perspective. Under emergent gravity, the universe begins to resemble not a mechanical system of forces, but a vast informational network in constant reorganization. The motion of galaxies, the orbit of planets, even the structure of black holes, all could be expressions of deeper statistical or informational laws. Gravity, in this sense, is not imposed upon matter. It is the result of matter participating in a deeper informational architecture. Ancient observers in regions such as Palestine carefully tracked the motions of the heavens, noting patterns in planetary movement, lunar cycles, and stellar alignment. To them, the sky was not chaotic, but structured, governed by principles that could be understood through careful observation. While they could not have imagined the language of entropy or quantum information, their intuition that order emerges from deeper patterns finds an unexpected echo in modern theoretical physics. Emergent gravity also intersects with one of the most mysterious realms of modern science: black holes. These extreme objects challenge our understanding of space, time, and information. When matter falls into a black hole, it appears to vanish from the observable universe, raising deep questions about what happens to the information it contained. Some theoretical approaches suggest that this information is not lost, but encoded on the surface of the event horizon, hinting again that space-time may be fundamentally informational rather than purely geometric. Could gravity itself arise from similar principles, encoded relationships between information, entropy, and geometry? If so, then the universe we experience as smooth and continuous may actually be the large-scale expression of something far more granular and abstract beneath it. Standing in the quiet valleys of Palestine, where light and shadow move slowly across ancient stone, it is easy to feel as though space itself is stable, permanent, and absolute. Yet emergent gravity invites us to reconsider even this most basic intuition. The ground beneath us, the pull that keeps us anchored, the orbit of the moon above, all may be manifestations of something deeper, something not yet fully visible to human understanding. This raises a profound question. If gravity is emergent, what is it emerging from? Some theories point toward quantum entanglement, suggesting that the connectivity between particles at the smallest scales gives rise to the very structure of space-time. Others propose that gravity emerges from thermodynamic principles, where the universe naturally evolves toward states of maximal entropy. Still others hint at unknown informational substrates, where reality is fundamentally computational in nature. And yet, none of these explanations are complete. The true nature of gravity remains one of the deepest open questions in physics. Even with Einstein's elegant equations describing space-time curvature, we still do not fully understand why gravity exists at all, or whether it is truly fundamental. Emergent gravity does not claim to solve this mystery. It expands it, suggesting that what we call reality may be a surface expression of something far more intricate beneath. As night settles once more over the hills of Palestine, the stars appear fixed in their familiar positions, and yet even their stability begins to feel less absolute under this new lens. Perhaps their motion is not governed by a force in the traditional sense, but by patterns emerging from a deeper, unseen order, an order built not from matter, but from relationships, information, and structure. And so we are left with a quiet but unsettling reflection. If gravity itself is not fundamental, then what lies beneath the architecture of space, time, and motion? What deeper layer of reality gives rise to the very stage upon which the universe unfolds? As the notion of gravity fades into something more subtle, an effect that may emerge from deeper, unseen layers of reality, the questions we face no longer concern just forces or structures, but the very evolution of the universe itself. If space-time is not fundamental, and if even gravity arises from hidden processes beneath it, then what governs the long-term behavior of the cosmos? Is the universe static in its underlying laws, or does it evolve, adapt, and perhaps even select its own future configurations? In the early morning stillness over the ancient hills of Palestine, mist drifts through valleys shaped by time beyond human memory. Olive trees stand rooted in soil that has witnessed countless generations, their forms shaped by wind, weather, and the slow pressure of centuries. Stone paths carved by human hands long ago now blend into the natural landscape, as if culture itself has been absorbed into geology. Here, everything feels shaped, not randomly, but through accumulation, pressure, and persistence. And in that sense, the land itself becomes a quiet metaphor for a far more radical idea, that even the universe might evolve through a process resembling selection. This is where the cosmological natural selection theory enters the conversation. Proposed by physicist Lee Smolin in the 1990s, this theory suggests that the universe may not be a singular, unchanging system with fixed laws, but rather something that evolves over time through a kind of natural selection, similar in a deeply abstract sense to biological evolution. Instead of organisms competing and reproducing, entire universes may be born, evolve, and give rise to new universes with slightly different physical constants. At the heart of the idea lies one of the most mysterious objects in physics, the black hole. In standard cosmology, black holes are regions of extreme gravity where matter collapses into a point of immense density from which nothing, not even light, can escape. But in cosmological natural selection, black holes are more than endpoints. They are potential gateways, or even seeds, for new universes. Each black hole could give rise to a new universe on the other side, with physical constants slightly altered from its parent universe. Over immense timescales, this would create a kind of cosmic genealogy. Universes that produce more black holes would, statistically speaking, generate more offspring universes. As a result, the multiverse would gradually become dominated by universes that are efficient at producing black holes. In this framework, the laws of physics are no longer fixed in an absolute sense. Instead, They are shaped by a vast generational process occurring across countless universes, each one slightly different, each one contributing to an unfolding cosmic lineage. It is a striking shift in perspective. Walking through the layered landscapes of Palestine, where ancient civilizations have risen, transformed, and left behind traces embedded in stone and memory, one encounters a similar logic of inheritance and adaptation. Cities grow, collapse, and are rebuilt. Cultural systems evolve in response to environment, conflict, and survival. Over time, patterns emerge, not because they were designed, but because they were selected through persistence and adaptation. Cosmological natural selection suggests that something analogous may be occurring on the scale of the entire universe. But unlike biological evolution, this process would operate without intention, without consciousness, and without purpose in any human sense. The universe would not be trying to become more complex or more stable. Instead, universes with certain properties simply persist longer or produce more offspring universes, gradually shaping the statistical landscape of reality itself. One of the most intriguing consequences of this idea is its potential to explain why the physical constants of our universe appear finely tuned for complexity and structure. The strengths of fundamental forces, the masses of particles, and the behavior of cosmic expansion all seem to fall within narrow ranges that allow galaxies, stars, and eventually life to form. Rather than invoking design or coincidence, cosmological natural selection proposes that we live in a universe that has been selected because it is particularly effective at producing black holes, and in doing so, has indirectly produced the conditions necessary for complexity. Yet this explanation is far from settled. There is, at present, no direct observational evidence that black holes give rise to new universes. The internal structure of a black hole remains hidden behind the event horizon, inaccessible to current measurement. The idea that new universes could emerge from such regions remains speculative, though it is grounded in extensions of general relativity and quantum gravity theories that attempt to reconcile the behavior of space-time at extreme scales. Still, the theory raises profound questions about the nature of existence itself. If universes can reproduce, what determines their fitness? Is it simply the number of black holes they produce, or are there deeper, more subtle criteria embedded in the fabric of physics? And if physical laws can vary across universes, then what determines the space of all possible laws? Is there a meta-law governing the entire multiverse, or does even that concept dissolve under closer examination? In this framework, the universe ceases to be a static stage and becomes something far more dynamic, a system engaged in an ongoing process of variation and selection across incomprehensible scales of time and space. The cosmos is no longer a single story, but an evolving population of stories, each branching from the collapse of massive stars, each shaped by the hidden consequences of gravitational extremes. As night falls over Palestine, the sky opens into vast darkness punctuated by distant points of light. Each star, once a site of nuclear fusion and gravitational balance, may also be part of a far larger narrative, a universe within a lineage of universes, each one shaped by the remnants of those that came before. The familiar becomes unfamiliar when viewed through this lens. The sky is no longer just a collection of stars, but a potential map of cosmic ancestry written in light. And so the question arises, quiet but persistent. If universes can give birth to new universes, shaped by the structures they leave behind, then what does it mean to say that our cosmos is fundamental at all? And if we are the result of an evolutionary process on a scale beyond imagination, what other forms of reality might exist, hidden in the vast generational chain of cosmic selection, waiting to be discovered or never meant to be seen at all? As the universe itself may have evolved through hidden processes of cosmic selection, We turn now to a different kind of mystery, one that suggests that the very matter we see around us may represent only half of reality. Across the valleys and hills of Palestine, where the sun rises over olive groves and ancient stone terraces, a quiet symmetry pervades the landscape. Mountains mirrored in still pools, fields reflecting the soft light of dawn, and human activity tracing patterns that repeat over generations. Yet beneath this tangible symmetry, some physicists have begun to speculate that nature itself may possess a hidden mirror, a realm of matter that exists alongside our own, invisible and yet equally real. This is the enigma of mirror matter. The concept is deceptively simple, yet profoundly unsettling. Mirror matter theory posits that for every particle in the universe we know, the electrons, protons, and neutrons that compose stars, planets, and people, there exists a counterpart, a mirror particle that interacts with the world we see primarily through gravity. These mirror particles would form mirror atoms, mirror molecules, and possibly entire mirror stars and mirror galaxies. They would be invisible to conventional detection, passing through ordinary matter without friction or light, yet exerting subtle gravitational effects that shape the cosmos. In the 1950s, the seeds of this theory were planted in the exploration of symmetry in particle physics. Physicists discovered that certain fundamental interactions in nature were not perfectly symmetrical. They violated a property known as parity. This asymmetry, where the behavior of particles does not perfectly mirror itself, posed a puzzle. If the laws of physics are universal, why should left-handed and right-handed systems behave differently? One radical solution was to imagine a mirror world, an invisible counterpart to our own, where the asymmetries are reversed, restoring balance to the universe at a fundamental level. Over decades, this idea evolved into a testable hypothesis. Could the universe be filled with matter that we cannot see, yet whose presence can be inferred from gravitational effects? Could dark matter, that mysterious substance making up roughly 85% of the universe's mass, be composed at least in part of mirror matter? Observations of galactic rotation, gravitational lensing, and cosmic structure hint at the presence of unseen mass, yet its nature remains elusive. Mirror matter offers one possible explanation, one that is elegant in its symmetry but challenging to confirm. The implications are staggering. Imagine for a moment that somewhere in the cosmos there exists a mirror version of Palestine. Mountains, rivers, and valleys, all constructed from mirror particles, invisible to our eyes, but present nonetheless. Could mirror stars burn in their own invisible fusion? Could mirror galaxies dance through gravitational fields, occasionally tugging at our universe in subtle, barely perceptible ways? And what of the black holes, the singularities that already defy our understanding? Could they be connected to mirror matter in some unseen cosmic dialogue? This idea, as abstract as it may seem, has tangible connections to experiments on Earth. Physicists have searched for signs of neutron oscillations, where a neutron might spontaneously transform into a mirror neutron and vanish from detectable matter, only to reappear later. While no definitive evidence has yet been found, the mere possibility suggests that the mirror universe could brush against our own in ways we are only beginning to understand. Even the familiar sunlight, the warmth of stone terraces, and the delicate sway of olive branches could, in theory, be accompanied by unseen mirror reflections of themselves, real yet imperceptible. Consider the history embedded in Palestine, a land layered with millennia of human activity. The stones, the ruins, the vestiges of civilizations long past, all carry the visible imprint of existence. Yet beneath and alongside this history, could there exist a parallel history composed of mirror particles, silently evolving in tandem with the visible world? Could there be mirror analogues to the structures we walk among, invisible but present, a hidden symmetry echoing our own civilization? Mirror matter theory also raises profound questions about identity and observation. If matter can exist in forms that are fundamentally undetectable except through indirect effects, then how much of reality do we truly perceive? Are the laws of physics we measure the complete story, or merely the shadow cast by a fuller, hidden cosmos? And if mirror matter is out there, what other phenomena, gravitational anomalies, unexplained cosmic rays, or even subtle deviations in planetary motion, might be evidence of its presence, waiting patiently for discovery? Standing once more on the hills of Palestine at twilight, with the last rays of sun casting long shadows across olive groves and stone terraces, the notion of mirror matter invites a reflection as unsettling as it is fascinating. Just as the landscape holds both visible and invisible histories, so too might the universe contain layers that are invisible to our senses but integral to its structure. Reality, it seems, may be far richer and stranger than our direct experience suggests. And so we are left with a quiet, lingering question. If a mirror world exists alongside our own, composed of matter that we cannot directly see, then what other hidden layers of existence might await discovery? How many unseen symmetries govern the cosmos, and what does it mean for our understanding of matter, space, and life itself? In the stillness of night, under the vast dome of stars, the universe remains a reflection we are only beginning to glimpse. As the possibility of hidden mirror worlds recedes into thought, we turn our gaze outward, beyond the familiar skies of Palestine, past the sun-dappled hills and ancient stone terraces, into the vast reaches of space where silence reigns and stars burn like distant beacons. Here, in the interstellar void, a quiet, almost poetic question emerges. Might life itself have traveled across the cosmos, carried not by design, but by the natural mechanisms of the universe? This is the enigma at the heart of Panspermia Theory. Panspermia proposes that life on Earth may not have originated solely on our planet. Instead, microscopic organisms, or the very building blocks of life, could have journeyed here aboard comets, asteroids, or interstellar dust, surviving the cold and radiation of space to seed our world. In other words, life may be cosmic, not terrestrial, with roots stretching across the stars themselves. Imagine the barren surface of a comet, a frozen, desolate object orbiting the sun, its surface crusted with ice and dust. Within that ice, encapsulated in minuscule grains, microscopic life, or prebiotic molecules capable of forming life, might endure. Then, through gravitational nudges or collisions with larger bodies, this tiny vessel is ejected into space, drifting through light years of near absolute darkness. It traverses the solar system, perhaps wandering from star to star until a chance encounter brings it to a young planet, like Earth, teeming with raw chemical potential. Could the spark of life we know have been delivered in such a silent, improbable journey? The idea is not entirely new. Philosophers and scientists as far back as the Greek thinker Anaxagoras speculated on seeds of life dispersed throughout the cosmos. In the 19th and early 20th centuries, scientists like Svante Arrhenius advanced the concept scientifically, suggesting that spores might travel through space, propelled by radiation pressure. Modern research has only deepened the intrigue. Studies of meteorites have revealed organic molecules, some complex enough to suggest the rudiments of life. Observations of comets show that they carry a rich chemical cocktail, including amino acids, the building blocks of proteins essential for life. Yet panspermia is not merely a chemical hypothesis. It is a cosmic narrative that challenges our sense of origin and isolation. If life can traverse the void, then Earth may be less an isolated cradle than part of an interstellar web, connected in subtle, profound ways to other worlds. This view reframes our place in the universe. We are not a singular occurrence, but potentially one chapter in a story that spans countless stars and untold distances. Consider Palestine's ancient landscapes, where civilizations rose and fell over millennia. Just as life on Earth evolved across shifting climates and continents, perhaps life itself migrated across the cosmos, adapting to new environments as it moved. Could the first microbial forms to take root in the primordial oceans of Earth have been travelers from distant worlds, carrying genetic whispers of alien suns? Evidence for panspermia remains tantalizing, but inconclusive. The harsh environment of space presents formidable barriers. Cosmic radiation, extreme cold, and high-velocity impacts would seem to destroy fragile organisms. Yet some extremophiles, microbes resilient to radiation and desiccation, demonstrate that life can survive in conditions far harsher than previously imagined. Laboratory experiments simulating space conditions have shown that certain bacterial spores can endure years of vacuum and radiation. It is a small but significant hint that the universe may indeed be hospitable to the transport of life. Beyond the technical details, panspermia raises profound philosophical and theological questions. If life arrived from elsewhere, does that diminish its sacredness or uniqueness, or does it expand our sense of the divine tapestry of creation? In every comet streaking across the sky, in every dust particle drifting between stars, could there lie a hidden connection, threads of life weaving together the cosmos in ways we are only beginning to perceive? Observational astronomy continues to push the boundaries of our understanding. Spectroscopic studies of distant stars reveal disks of gas and dust, the raw material for planetary systems. Within these disks, complex organic molecules have been detected, hinting that the potential for life may be widespread, perhaps ubiquitous. Yet despite these discoveries, the origin of life on Earth remains an open question. Was it local, born from the churning primordial soup? Or was it a gift from the stars, a seed carried across light years of emptiness? In the quiet of a Palestinian night, under a sky filled with countless stars that have shone for billions of years, one cannot help but feel the immensity of possibility. Perhaps each star harbors its own story of life, some similar, some utterly alien, all connected through the subtle mechanics of the cosmos. Panspermia invites us to expand our imagination, to consider a universe not as a backdrop for our existence, but as an active participant in the spread of life itself. And yet, for all its elegance and scope, the theory leaves us with a haunting question. If life came to Earth from the cosmos, from which corner of the universe did it originate? Are we part of an ancient chain of life stretching across galaxies, or were we among the first to awaken? The mystery endures, quietly urging us to look both outward, toward the stars, and inward, toward the microscopic origins of our own existence. In this light, the Panspermia theory is not merely a hypothesis of biology or physics. It is a meditation on connectivity, on the delicate threads that might bind planets, stars, and civilizations across space and time. And as the wind stirs the olive trees and the stars reflect in still pools, we are reminded that our place in the cosmos may be both smaller and more profound than we have ever imagined. The universe, it seems, may carry life as patiently as it carries light, whispering secrets across the dark, vast void, waiting for those who dare to listen. As the idea of life seated across the cosmos begins to fade into the distance, carried on comets, drifting through interstellar darkness like a silent, ancient inheritance, we return once again to something closer, more intimate, yet no less mysterious. Not the origin of life across space, but the origin of thought itself. Where does the mind end, and where does the world begin? In the early morning stillness over the terraced hills of Palestine, light spread slowly across the landscape. Olive trees cast soft, shifting shadows over stone paths shaped by generations of human presence. A shepherd's movement in the distance, the faint rustle of wind through dry grass, the distant echo of birds breaking the silence. Each detail feels external, separate, observed. And yet, there is a quiet uncertainty beneath this apparent clarity. Are these experiences confined entirely within the brain, or do they extend beyond it in ways we have yet to understand? This is where the extended mind hypothesis begins to take shape. At first, it appears almost modest, a philosophical suggestion rather than a scientific revolution. Proposed in modern cognitive science by philosophers such as Andy Clark and David Chalmers in the late 20th century, the hypothesis challenges a deeply ingrained assumption that the mind is contained entirely within the skull. Instead, it suggests something far more expansive. The mind, it argues, may not be strictly internal. It may extend into the environment, integrating tools, objects, and external systems as active components of cognition itself. To understand this, consider something simple: a notebook. When a person writes down a phone number, they are outsourcing memory to the page. But under the extended mind hypothesis, that notebook is not merely a tool, it becomes part of the cognitive system. The act of remembering is no longer confined to neural activity. It is distributed across brain, body, and environment. The boundary of the mind becomes porous, fluid, and strangely incomplete without the world around it. Now imagine this principle expanded beyond notebooks and devices, extending into landscapes, architecture, language, and even social systems. Walking through the ancient villages scattered across Palestine, where stone houses stand layered with centuries of human thought and culture, one begins to sense how deeply environment and mind intertwine. The winding streets are not just pathways, they are memory structures. The carved stones are not just architecture, they are externalized cognition, preserving decisions, beliefs, and ways of seeing the world across generations. In this sense, human thought is not only something that happens inside individuals, but something embedded in the very structure of inhabited space. The extended mind hypothesis builds on a growing body of research in cognitive science, neuroscience, and artificial intelligence. Studies of tool use, language processing, and memory recall suggest that human cognition is deeply dependent on external scaffolding. Language itself can be seen as an extension of thought, allowing ideas to exist beyond the fragile limits of biological memory. Written records preserve knowledge across centuries, effectively extending the lifespan of human cognition far beyond a single brain. But the hypothesis does not stop at practical tools. It raises a more unsettling possibility, that consciousness itself may not be strictly localized. When a person navigates familiar terrain, solves a complex problem, or engages in deep conversation, cognition appears to emerge from a dynamic interaction between brain, body, and environment. The brain alone does not hold the entire process. Instead, it coordinates a network of external and internal elements. Even perception becomes distributed. The eyes gather light, the brain interprets signals, but meaning arises only through interaction with the world. In the quiet landscapes of Palestine, this interplay becomes almost tangible. A person walking through olive groves does not simply observe the environment, they participate in it cognitively. The spacing of trees, the texture of soil, the shifting light across stone walls, all become part of a larger cognitive loop. The environment is not passive. It is structured in ways that support memory, orientation, and meaning-making. The mind, in this view, is not confined within the body but extended into the space it inhabits. Some interpretations of the theory push even further. Could digital systems, smartphones, and networks now function as extensions of human cognition? If a search engine holds information we rely on instantly, does it function as an external memory system? If communication networks shape how we think and decide, are they part of the cognitive architecture itself? The boundaries begin to blur, and the question of where the mind ends becomes increasingly difficult to answer. Yet, like many theories at the edge of understanding, the extended mind hypothesis is not without controversy. Critics argue that while tools and environments assist cognition, they are not truly part of the mind itself. They remain external supports, not components of consciousness. The distinction may seem subtle, but it carries profound implications. If everything that assists thought becomes part of the mind, then where does the mind stop? Does it extend indefinitely into the world, or does it require a clear boundary to remain meaningful? And yet, even skepticism does not fully dissolve the mystery. Because experience itself often feels more integrated than the strict separation between brain and world would suggest. Memory is triggered by places. Thoughts are shaped by surroundings. Identity is influenced by culture, language, and environment in ways that are not easily disentangled from cognition. Standing at dusk among the rolling hills of Palestine, where light and shadow merge across ancient stone, it becomes difficult to maintain a strict separation between observer and observed. The landscape seems to participate in thought itself, shaping attention, guiding reflection, anchoring memory in physical space. It raises a subtle but persistent question. Is the mind something we carry inside us, or something we continuously assemble through our interaction with the world? The extended mind hypothesis does not provide a final answer. Instead, it gently destabilizes the assumption that cognition is purely internal. It invites us to reconsider the possibility that thinking is not confined to neurons alone, but distributed across bodies, objects, spaces, and perhaps even time itself. And so we are left with a quiet uncertainty, lingering like the last light of day over the horizon. If the mind extends beyond the brain into the world, then where exactly does consciousness reside? And how much of what we call self is actually the environment thinking through us? As the sun dips behind the rugged hills of Palestine, its golden rays catch the edges of ancient olive groves, casting long, fragmented shadows across terraces that have been walked for millennia. The wind carries whispers of the past, stirring the dust and loose stones as if revealing a hidden order that has always existed, yet remains just beyond comprehension. In this quiet, almost sacred stillness, we confront one of the most confounding questions in modern physics. What is the true nature of reality itself? Where previous theories have imagined consciousness extending through space, or universes folding upon themselves, the relational quantum mechanics interpretation asks a different, more subtle question. Can reality itself exist independently, or does it depend fundamentally on the relationships between observers? This interpretation, first proposed in the late 20th century by physicist Carlo Rovelli, emerged from the mathematical formalism of quantum mechanics, a framework that has both baffled and enthralled scientists for over a century. Quantum mechanics is notorious for defying common sense. Particles exist in multiple states simultaneously, their properties only crystallizing upon observation. Traditionally, physicists sought objective reality behind the mathematics, a singular universe waiting to be discovered. But relational quantum mechanics challenges that assumption entirely. Imagine a single atom suspended in a laboratory. According to classical intuition, it possesses inherent properties: position, momentum, spin. Yet, in the relational view, these properties do not exist in isolation. They are meaningful only in relation to other systems: the experimenter measuring the atom, the instruments used, even other particles interacting with it. There is no absolute state, only a web of interdependent facts, each contextual, each conditional upon interaction. This idea reframes our understanding of observation itself. Observation is no longer a passive act. It becomes a creative one, an intimate dialogue between systems. Just as a painter brings a canvas to life through brush and color, so too does measurement bring quantum reality into a particular form. Yet, unlike a painting, the result is not fixed or universal. Different observers, different systems, may witness entirely different realities, each equally valid within its own context, yet irreducible to a singular objective truth. To grasp this, one might turn to the timeless landscapes of Palestine once more. Consider a stone terrace beneath a sprawling olive tree. From one perspective, it is a path shaped by centuries of human footsteps, a testament to enduring culture. From another, it is a habitat for insects, a locus of mineral and microbial interactions, a dynamic microcosm. Both views are correct, yet neither alone captures the full tapestry of reality. The terrace exists relationally, depending upon the interactions that bring its various aspects into focus. In this way, the hills themselves offer a natural metaphor for a universe defined by relationships rather than absolutes. Historical experiments in quantum mechanics have long hinted at this relational nature. The famous double-slit experiment, in which electrons create interference patterns when unobserved but behave as particles when measured, exemplifies the conundrum. Under relational interpretation, the electron's behavior is not paradoxical but contingent. Its properties manifest only through interactions, not in isolation. Likewise, entangled particles, once considered a spooky action at a distance, can be understood as expressing relational correlations, revealing the fundamental interconnectedness of all systems in ways that defy classical intuition. Yet the implications stretch far beyond laboratory apparatus. If reality itself is relational, what does this mean for the universe at large? Could space and time emerge as macroscopic approximations of underlying quantum relations, rather than existing as fundamental entities? Might cosmological phenomena, from the birth of galaxies to the echoes of the cosmic microwave background, reflect not absolute states, but the intricate interplay of countless observers, physical or otherwise, interacting across vast scales? In this view, the cosmos is not a static backdrop, but a living network of interactions, each observation a thread in an ever-shifting tapestry. Even consciousness enters this dialogue in unexpected ways. If matter itself is relational, might perception, our very experience of existence, also be fundamentally relational? Could the self, like the electron, acquire definitive properties only in relation to the world it observes, entangled with objects, environments, and other minds? The distinction between observer and observed blurs, inviting a radical rethinking of identity, knowledge, and reality itself. Critics caution against overextending these metaphors, noting that relational quantum mechanics, while elegant, remains a formal interpretation with specific technical constraints. Yet its provocative insights persist, suggesting a universe in which context and connection are primary, where the act of measurement is inseparable from the phenomena measured, and where the notion of an objective, observer-independent reality may itself be an illusion. As the twilight deepens over Palestine and shadows lengthen across ancient olive groves and stone walls, one senses a profound humility before the universe. The relational quantum mechanics interpretation does not offer easy answers. It invites us to reconsider the very framework through which we understand reality. Each observation, each interaction, becomes part of a vast, interdependent network, a universe whose truths are never isolated, never absolute, but eternally intertwined with the observers that bring them into being. And so, standing at the threshold between shadow and light, past and present, we are left with a lingering question. If reality is fundamentally relational, then whose reality are we witnessing? And how many layers of observation remain hidden, waiting to emerge from the subtle dance between systems? In the quiet of the hills, the mystery endures, inviting us to wonder whether the universe exists independently at all, or only in the reflections of our interactions with it. The soft transition from relational quantum mechanics opens a path into a world where observation itself sculpts reality, not just through interactions between systems, but through a subtle, selective process that determines which aspects of quantum phenomena survive in the macroscopic world. Across the rolling hills of Palestine, ancient terraces cling to the earth. Olive trees sway in a languid breeze, and the quiet rhythm of life seems eternal. Yet, beneath this serene surface, a hidden order might be at work, one dictated not by inevitability, but by a process akin to evolution itself, a process physicists have called quantum Darwinism. This theory, first formulated in the early 2000s by Wojciech Zurek, seeks to explain a question that has haunted quantum physicists for nearly a century. How does the strange, probabilistic world of quantum mechanics give rise to the stable, classical reality we experience every day? Electrons, photons, and atoms fluctuate between multiple possible states, coexisting in superposition. The classical world, by contrast, feels definite, tangible, and objective. How does the quantum realm choose what becomes reality? Quantum Darwinism proposes an answer with a quiet elegance. Borrowing the metaphor of natural selection, it suggests that quantum states are continuously measured by their environments, and only certain states, those that are stable, reproducible, and capable of imprinting themselves on surrounding systems, persist. Like genes in biological evolution, the information that survives is the information that can be redundantly proliferated across the environment. Reality, in this view, is not simply observed. It is selected, copied, and reinforced by countless interactions, leaving behind a stable, classical world that seems independent and objective. Consider a beam of sunlight striking a stone wall in the hills. Photons scatter across surfaces, their paths influenced by countless interactions with molecules in the air, the wall, and our eyes. Most quantum possibilities vanish, decohering into probabilities that never manifest in ways we can perceive. Yet some fit the environment better. They are redundant, robust, and easily observed. They proliferate, while others fade into irrelevance. The texture of the wall, the sheen of the leaves, even the way our consciousness perceives the scene, all emerge from this subtle filtering process. In experimental physics, evidence for quantum Darwinism has been found in carefully controlled laboratory setups. Scientists have observed how photons or ions, when interacting with complex environments, leave redundant imprints that are accessible to multiple observers without disturbance. These studies suggest that classical reality may indeed arise from the survival of information that can be redundantly recorded, a cosmic process that ensures certain features of the universe become objective. Yet, as elegant as it is, the theory challenges the assumptions of objectivity at a fundamental level. Reality, under quantum Darwinism, is not absolute. It is emergent, shaped by the environment and the proliferation of information. This introduces a profound twist. What we perceive as stability and definiteness is the product of selection at the quantum level. Could it be that the solidity of a mountain, the patterns of the stars above the Palestinian hills, even the reliability of our memories, all arise from a quantum survival of the fittest? The implications stretch far beyond the laboratory. If information is the key to what persists in the universe, then the act of observation, by humans, by any complex system, by the environment itself, is central to reality's unfolding. Classical objects, time and space emerge as stable structures precisely because they have survived this relentless filtering process. Our sense of a shared, objective world is a testament to the redundancy of quantum information, the echo of countless interactions amplified across space and time. Historical context further enriches this perspective. From the earliest human civilizations in Palestine, where astronomers charted the night sky and farmers mapped the seasons, to the precise quantum experiments of the modern era, humanity has always sought patterns in the chaos of nature. Quantum Darwinism offers a new lens. The patterns we observe are not merely a reflection of our perception, but the outcome of an ancient, universal selection process, a quiet arbiter shaping what is visible from the vast potentialities of existence. And yet, as with all frontiers of understanding, mystery remains. Can quantum Darwinism fully account for the emergence of consciousness or the particular structure of complex systems? Or is it merely one layer in a far deeper hierarchy of natural laws? If reality is indeed a product of information that survives interaction, what of those possibilities that never manifest, the myriad ghosts of quantum potential that never leave a trace? Do they persist in some hidden dimension, inaccessible but real? As night falls over Palestine, and the first stars emerge like faint impressions of ancient light, the hills seem to hum with an invisible order. Each twinkling point, each shadow between olive trees, reflects not merely photons and matter, but the echoes of countless interactions, filtered and reinforced across time. Quantum Darwinism does not promise certainty. It offers a framework to wonder at the quiet processes that shape reality itself. Standing in this twilight, we are left to ponder: is the classical world truly objective, or merely the surviving chorus of information that has endured the rigorous sieve of the universe? What countless possibilities never made it through, and how might those unseen realities inform our understanding of existence? In the end, the theory leaves us with a profound sense of awe, a reminder that the world we see is both more fragile and more wondrous than it appears, and that the hidden mechanisms of reality continue to invite our curiosity. Seamlessly moving from the subtle selection of reality proposed by quantum Darwinism, we now turn to a concept that challenges one of the most sacrosanct pillars of modern physics: the constancy of the speed of light. Across the vast deserts and ancient cities of Palestine, where the wind whispers over time-worn stone and the horizon shimmers under the relentless sun, light appears as a constant companion, swift, unwavering, and eternal. Yet, what if that familiar speed, so foundational to our understanding of space and time, were not as immutable as it seems? The variable speed of light, VSL. Theory suggests exactly this, that the speed of light may have fluctuated across cosmic history, altering the very framework of the universe. Albert Einstein's relativity has long held that light in a vacuum travels at a fixed speed, approximately 299,792 kilometers per second, a limit enshrined in the laws that govern everything from the trajectories of planets to the behavior of distant galaxies. But what if, billions of years ago, during the earliest moments of the cosmos, light surged faster or crawled slower than it does today? Could such variations solve some of the deepest mysteries of cosmology, from the uniformity of the cosmic microwave background to the expansion of space itself? The origin of this radical idea can be traced to puzzles in the standard cosmological model. Observations of the early universe reveal a striking homogeneity. Regions of space so far apart appear to share nearly identical properties, despite being separated by distances too vast for light to have traveled between them. This horizon problem has traditionally been addressed by the theory of cosmic inflation, a sudden and extreme expansion of space shortly after the Big Bang. Yet some physicists have proposed an alternative. If light itself traveled faster in those early moments, information and energy could have propagated far more rapidly, ironing out irregularities across the universe without invoking inflation. In VSL scenarios, the speed of light is no longer a static constant. It becomes a dynamic quantity, potentially dependent on time, energy, or other cosmic conditions. Such a shift has profound implications. The structure of atoms, the formation of stars, the behavior of gravity, all may have been subtly influenced by fluctuations in light's velocity. Even the passage of time, intimately linked to the transmission of electromagnetic signals, could take on a different rhythm across epochs of varying light speed. To explore this idea, scientists look to both theory and observation. Measurements of the cosmic microwave background, the faint afterglow of the Big Bang, carry encoded information about the early universe's expansion. Astronomical data from distant quasars and galaxies suggest the possibility, though still highly debated, of tiny variations in fundamental constants over billions of years. Could these be hints of a time when light itself danced to a different cosmic tempo? The VSL theory also carries echoes of philosophical and historical reflections on light. Ancient scholars in the cities of Palestine studied the heavens, charting the movement of celestial bodies and pondering the nature of illumination and perception. For them, light was both a physical and a metaphysical phenomenon, guiding navigation, ritual, and understanding. The notion that light's speed could vary over time resonates with this duality, a bridge between the measurable universe and the profound mysteries of existence. Yet, the theory remains contentious. Altering the speed of light strikes at the heart of relativity, demanding careful reformulations of the equations that govern motion, energy, and causality. Critics caution that VSL risks undermining the elegant simplicity of established physics. Proponents, however, argue that challenging conventions may be necessary to explain phenomena that stubbornly resist standard models. Could the universe itself be subtly rewriting its rules, leaving traces of ancient velocities for us to detect in the patterns of starlight and cosmic radiation? Consider the deserts stretching between Jericho and Hebron, where heat shimmers off stones and horizons blur into mirages. If light's speed were once different, would the very shape of the sky above these landscapes have been altered? Could ancient photons, carrying the signature of a faster or slower journey, still whisper secrets about the infancy of the cosmos? And if so, what might this tell us about the laws we take for granted, the constants we assume eternal? Observations continue, from the most sensitive spectrographs to satellite missions peering deep into the early universe. Each photon captured may carry a message not only about distant galaxies, but also about the underlying principles of reality. In contemplating a universe where light is not fixed, we confront questions that extend beyond physics: the nature of time, the unfolding of cosmic history, and the interplay between human perception and the deep structure of the cosmos. As twilight descends over Palestine, illuminating the olive groves and ancient city walls in a soft, golden glow, one cannot help but reflect on the fragile certainties of our knowledge. The stars overhead, whose light has traversed eons, may themselves carry imprints of a variable speed, a hidden rhythm of the universe that only now begins to reveal itself. What truths might we uncover if we dare to consider that light, the very medium by which we perceive reality, has not always been the same? And if the speed of light can vary, even slightly, what does that suggest about the fabric of space, the march of time, and the unfolding of existence itself? In this quiet, contemplative moment, the theory invites a profound and unsettling question. Are the cosmic constants we rely upon truly universal? Or are they the fleeting notes of a symphony whose tempo has subtly shifted over the course of time? The answer remains unknown, hidden in the delicate interplay between observation, theory, and the universe itself, waiting for the next insight, the next measurement, the next daring leap of imagination.